Make sure to like and subscribe right now. Yes, do it.
This is Ronan from MathX, and today we'll be solving the AIME 2024 number 6 part 1. Now this problem is a bit more on the difficult end, as it involves multiple math concepts to solve it. But using some tricks and some skills, we'll be able to solve this problem in no time. Anyways, without further ado, let's get started. Consider the path of length 16 that follows the lines from the lower left corner to the upper right corner on an 8x8 grid. Find the number of such paths that change direction exactly 4 times, as in the examples shown below. Now, what we can do first in solving this problem is that we can kind of simplify this down by kind of having the turns identified as letters. So, in these examples precisely, they turn, in this diagram at least, they turn right 3 times and up 2 times, meaning there'd be like 5 different situations for them moving. So, there are 2 cases here of RU, 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 with R being right and U being up. And then there's another situation where they could go U, R, U, R, U, which is in the second diagram, where they go up, then right, then up, then right, then up. Now, because these two are basically without loss of generality, as they both represent the same cases, when we're finalizing our answer, we can just multiply by 2, as it'll be for each individual case of the turning maneuvers. Now, we can use for calculating this, let's just use the first case, and we can use the terms U and R for representing it. Now, in the first case, we will have 7 kind of ordered pairs for where it could be turning at. And we know this because the terms in the coordinates of the grid for the points would have to add up to 8 so we can accurately have the turning. So to make this a bit more clear, for it to turn at any given point, it would have to be like either here 8, 0, which wouldn't be necessarily working in this case, as that implies that the problem means that there's only being 1 point of turn. But it'd be more like, instead of that, it can be 8, 0 or the 0, 8, but instead it would have to be the points within. So it would be having 7 different ordered pairs of positive integers, so that a plus b is equal to 8, which would be 1, 7, 2, 6, 3, 5, 4, 4, and all that. So, because there'd be 7 ordered pairs for those positive integers to turn at, we can have 7 here, as next we're going to be multiplying it by the next term. Now, for the right situations in this, we can subtract 1 from each of the sections. So basically, the sections of moving in where it goes just in a straight line. Yeah, like here, how it goes 3 in a straight line, we just subtract 1, because that would be accounting for the cases that each section would have 0. So now that we kind of understand that, we have to do stars and bars for it. Because by using stars and bars, we can find the combinations of where we can separate out the right points and the up points. So as we're subtracting by 1, we would have to do 8 minus 1, and then we would have to choose the 5 different points for it to go up, right, up, right, up, right. Now, it's not exactly 5, as this is 4 times in the problem, but to make it a bit more clear, it's also including the starting point of whatever direction it goes in. So you would have to choose 5 from that. So we can do 8 minus 1, so that would be equal to 7. Then from that, we can just write it out here, so it's a bit more understanding. Choose. And then we can put 5. Which we know that 7 choose 5 would be just equal to 21. So now that we have that kind of labeled out, we can do 7 times 21, then times 2, as we were first accounting for both of the cases there. So 7 times 21 times 2 would be equal to 294. And that is the answer to our problem. 294. Thank you for watching this Mathix video, and if you guys have any suggestions or any other problems you'd like us to do, please let us know in the comments. And for watching, and see you next time.